All right, here is Unit 2, Lesson 4. We're going to talk about compound inequalities, and there's going to be 2 days of this. So day 1, we're going to focus on solving and graphing and inequalities. So just kind of introduce this. A compound word is when you have 2 words put together. So dog, house, keyboard, basketball. Okay, so a compound inequality is kind of the same thing. Compound inequality then is 2 inequalities put together. So there are 2 types of these that we're going to talk about the next 2 days. One type is and the other one is or. Okay, today we're going to focus on or, and then tomorrow we'll do, I'm sorry, I just said or, and then tomorrow we're going to do or. So for all numbers that are, we want to write an inequality here. So for all numbers that are greater than 2 and less than 9. Well, the first one is all numbers greater than 2. So that'd be all the numbers greater than 2. The other one would be all numbers less than 9. Now we want to put those together. Okay. When you do this, make sure your arrows point left. Okay, so arrows need to point left, and you want to go from least to greatest. So between 2 and 9, 2 is first, 9 is second, and n is larger than 2, but it's less than 9. Okay, so it's all the numbers between 2 and 9 basically. So you're thinking like 3, 4, 5, 6, 7, and obviously all the decimals in between, like 2.5, 3.5, 2.25, all those decimal numbers too. So a solution to this is a number that makes both true. So like I could say 0. 0 makes this true because 0 is less than 9, but 0 is not greater than 2. So 0 would not be a solution. 3 is less than 9 and it's greater than 2, so it does make it true. Okay, since again there's going to be infinite number of solutions, so we need to graph it. We can't list them all. It'd be impossible to list all of them. So we're going to graph it. So my endpoints here are 2 and 9. So 2, 9. These are both not equal to, so they're going to be both open circles. And then I want the numbers between them, so I'm going to shade between. Okay, so there's the graph of that compound and statement. Next question. Monday's high, I wish this was true, Monday's high temperature was 73 and the low temperature was 51. So show all temperatures from Monday. So it had to be everything in between. It couldn't just jump straight from, say, 50 to 60 without going 51, 52, 53 in between. So that means all the temperatures, okay, were between 51 and 73. So go least to greatest, 51, 73. And we're going less than or equal to, okay. Let's see here. So now if I want to graph these, go 51, 73, and then these are equal to, because it says the low was 51. So it equaled 51, and the high was 73, so it equaled 73. So these are closed circles, and everything in between. Okay, so to solve these and inequalities, because now there's nothing to do those. Now we're going to have to do some solving. When we need to solve, like say this one down here, I want to get x by itself. Okay, so I need to isolate, just like any other equation inequality. However, the variable is in the middle of 2 inequality symbols. So these 2 inequality symbols create 3 sides to an inequality. We're used to having 2 sides. Now we're going to have 3 sides, which kind of sounds weird. But whatever you do to the middle inequality, you have to do the same thing to all 3 sides. Okay, so this guy down here, when I want to solve this guy, I want to get x by itself, I need to add 5 to that. So if I add 5 to this side, I got to add 5 over here and over here. So whatever you do, you're going to do it 3 times, 3 different places. Okay, so negative 4 plus 5 is 1. Here it's x. And then here it's 8. Okay, so that's my 1 is less than x, which is less than or equal to 8. And then when I go to graph that, here's 1, here's 8. Okay, not equal to, so open circle. Equal to, so closed circle. And then shade between. Okay. Now, let's flip this over. I'm going to go kind of fast through some of these because we're already at 5 minutes on the video. I don't want to make a super long video doing this, but all the same rules apply also. Like if I multiply or divide by a negative, I need to switch the signs, and I'm going to switch all the signs. Okay, so keep that in mind. So this guy here, if I want to get x by itself, I need to divide by 3. Well, if you do it to 1, you got to do it to all of them. So now, I divided by a positive, so the signs are going to be the same. Negative 12 divided by 3 is negative 4. This would be x. This would be negative 1. Okay, so x is between negative 4 and negative 1. And when I go to graph this guy, so negative 4, negative 1, I'm going to put closed circles because they're both equal to, and then shade everything between. Okay. The next one, this guy here, is going to take a couple of steps to get x by itself. So I'm going to write kind of small here, but I would want to multiply everything by 4 because I want to get rid of that 4 first. So I'm going to take this times 4, and times 4. So they're all being multiplied by 4. So in the middle, I'd have 3x minus 1. Sign doesn't change because I multiplied by a positive, so it's okay. And then negative 15 times 4 is negative 52. Okay. Now I want to add 1. So add 1, but do it to everything. So now I've got negative 51 less than or equal to 3x, which is less than 21. Okay, now divide everything by 3. Okay, so I got negative 17. Again, I divided by a positive, so these signs don't switch. They stay where they're at. So that would be my inequality. Sorry, my light shut off on me. To graph this guy, notice 1 is an equal to and 1 is not. So I got equal to and I got not. So I got negative 17 with a closed circle. And I got 7 with an open circle. And shade everything between, because anything between negative 7, if it's larger than negative 17 but less than 7, then it counts. So shade everything between. Okay, next guy. And think, how would I get x by itself here? A couple ways you could do this. You could distribute the 2 out, but I want to get x by itself, so instead of distributing, I'm going to just get rid of the 2 right now. I'm going to divide by 2. So if I divide everything by 2, I would have negative 4, x plus 5 and 5, and I divided by a positive, so the signs stay the same. Now subtract 5 from everything. So I get negative 9, x, and 0, and the signs stay the same because I didn't multiply or divide by negative, so it stays the same. So I've got a closed circle at negative 9, and a closed circle at 0, and everything in between. Okay. Let's see here. How about you guys try this one? So complete this yourself. Okay. Let's go to the last one here now. Pay very close attention to this guy. There's some weird stuff's going to happen. It'll be easier to rewrite it when we get there. So first step here, if I want to get x by itself, get rid of that 3. It's a positive 3, so I need to subtract 3. So we got negative 10. Again, I did not multiply or divide by a negative. I subtracted, so the signs are going to stay the same. And this would be 8. Now I need to divide by negative 2. Red flag, I divided by a negative. So as I write these answers, I'm going to switch the signs right now so I don't forget. Okay, so I got negative 4 over here. I've got a 5 over here. So that is okay. That is a true statement. So 5 is greater than x, which is greater than or equal to negative 4, but we always want to write it from least to greatest, and we want the arrows pointing to the left. So if I flip this whole thing over, I got negative 4, x, and 5. Between the x and the negative 4, I did have a greater than or equal to, and the arrows pointing to negative 4. I want the arrow pointing to negative 4 with equal to with it. Between the x and the 5, I had just a greater than symbol, no equal to, but it was pointing at the x, so I want to keep it pointing at the x. Okay, so this is going to make it way easier to graph. Okay, so when I go to graph this guy, negative 4, 5, there's a closed circle, open circle, and everything in between. Okay, so yeah, that's the AND statements, and we'll work on OR tomorrow.